Imagine a visitor from another star system, paddling through our solar neighborhood at 137,000 miles per hour speed so extreme it defies every model astronomers have built about how objects move in stars. Now picture that this intruder isn't just fast, it's massive. At 7 miles wide. This interstellar wanderer makes our previous cosmic guests look almost laughably small. If the much-debated Oumuamua was a single grain of rice, then 3I, Atlas, is a bowling ball crashing through the dinner table. The difference is not just size, it's statistical impossibility. According to the numbers, we should have discovered millions of smaller interstellar objects first before ever finding one. Like this, and yet, here it is sitting right in front of us, rewriting the rules of what can exist between the stars, but sheer scale is only the beginning. This object carries a chemical fingerprint that should not exist in nature. It breathes carbon dioxide instead of water. It bleeds nickel but refuses to give off iron. It contains cyanide in concentrations so bizarre that some scientists have whispered about artificial origins, and it has survived a journey not of centuries or millennia, but potentially billions of years longer than many galaxies have even existed. This is the story of 3I, Atlas, a cosmic missile, a chemical anomaly, and a time capsule from the galaxy's most ancient epoch. Its discovery has not only shocked astronomers, it has forced us to ask questions we never thought we would face. Questions about chemistry, about planetary systems, about the very odds of existence. And as you'll soon see, the deeper scientists looked into 3I, ATLAS. The stranger and more impossible the story became. But before we dive into its mysteries, let's go back to the moment humanity first spotted this cosmic visitor, on July 1st, 2025. The night sky looked ordinary, but in the desert mountains of Chile, the Atlas telescope network was sweeping the heavens as it always does. These robotic sentinels are designed to watch for anything unusual: asteroids, comets, even potential impact threats. Every clear night, they capture hundreds of gigabytes of sky images, feeding them into artificial intelligence systems trained to catch the faintest hint of movement against the backdrop of stars. That night, the algorithms flagged something strange, a faint dot, barely distinguishable from background noise, moving just fast enough to break the expected patterns. At first, astronomers assumed it was an error. False positives are common: cosmic rays hitting the detectors, satellites streaking through images, even birds that happen to cross the telescope's field of view. But the AI wasn't fooled. Across multiple images, the dot moved consistently. When scientists ran the orbital math, their jaws dropped. This was no asteroid. This was no ordinary comet. The calculations revealed a trajectory so hyperbolic that it could mean only one thing: the object wasn't bound to our sun. It had entered our system from interstellar space, would swing once round the sun, and then vanish forever. Its orbital eccentricity wasn't just above 1, it was a staggering 6.1 for 1. Far beyond anything natural in our planetary neighborhood. Within hours, observatories across the globe were turned toward this cosmic intruder. Data poured in: brightness, size estimates, velocity measurements, and the more scientists learned, the less sense it made. The speed was absurd. The trajectory was almost perfectly aligned with our solar planar probability of less than 0.2%. Already, whispers began to spread in astronomical circles. This shouldn't exist. The odds are impossible. And yet, the real shock came when the first chemical signatures began to arrive. To understand why 3I, ATLAS stunned scientists, we need to talk about speed. When astronomers measured its motion, they found something chilling: a hyperbolic excess velocity of 58 kilometers per second. This wasn't just fast, it was violent. That number carried within it a hidden truth. This object had been blasted out of its home star system with so much force that it not only escaped planetary gravity, it broke free from the gravity of its parent star itself. Think about that. Escaping a planet S-pool is one thing. It tests what we do every time we launch a spacecraft from Earth. But escaping the entire gravitational embrace of a star requires something catastrophic, something big. So what could create such a violent ejection? Scientists offered 3 scenarios, each more dramatic than the last. Planetary slingshot. Imagine a distant system with Jupiter-like giants dancing too close to one another. Their gravitational fields become weapons, flinging smaller objects like marbles in a cosmic game of billiards. Most get tossed inward, crashing into planets or the star itself. But sometimes, rarely, an object gets hurled outward at escape velocity, blasted into interstellar exile. Dying star. In another possibility, the parent star swelled into a red giant, destabilizing its planetary system as its atmosphere expanded. Waves of energy blasted smaller icy bodies outward, ejecting them into the galactic void. Stellar encounter, perhaps to star systems past. Dangerously close, their gravitational fields colliding in chaos. Smaller objects in the outer regions, comets, asteroids, were ripped free, flung into the darkness. Whichever scenario birthed 3I, Atlas. One fact was clear. This object had endured violence of a scale we can barely comprehend. It had been torn from its home, flung into the abyss, and left to wander the galaxy for billions of years. And yet, despite all this 3I, ATLAS survived. Like a scarred refugee, it carried with it the chemical fingerprints of its origin, frozen in time. It was now a messenger from an ancient epic, drifting silently until our telescopes finally caught it. But what exactly was it carrying? That's where things take a turn from the incredible to the impossible. Because the chemistry of 3I, Atlas doesn't just challenge our models, it defies them outright. The first chemical readings of 3I, Atlas left astronomers speechless. For every comet we've studied in our solar system, the story is the same. Heat from the sun releases plumes of water vapor. That's what gives us those beautiful glowing tails, ice melting into gas, streaming across the void. But 3I, Atlas didn't follow the rules. Instead of water dominating its emissions, the detectors showed something completely upside down. Carbon dioxide was king. In fact, for every molecule of water, there were nearly 8 molecules of CO. That ratio shouldn't exist. It's as if someone had taken the blueprint for a comet and rewritten it backward. Even stranger, this wasn't a trickle. Measurements from the James Webb Space Telescope revealed that the comet was venting 129 kilograms of carbon dioxide every second, the equivalent of a small car. Its exhaust pouring out continuously, not from an engine, but from an object larger than Manhattan, barreling through space. And the surprises didn't stop there. Among the chemical signatures were cyanide compounds. The same toxic molecules that terrify life on Earth, but also serve as building blocks for more complex organic. Cyanide isn't unusual in comets, but in 3I, Atlas, the ratios were bizarre, out of alignment with every pattern seen before. Then came the most jaw-dropping discovery. Nickel vapor was streaming out of the object, but there was no iron at all. Anywhere in the universe, nickel and iron travel together. They're forged side by side in the nuclear furnaces of stars, bonded into planetary cores, mixed into asteroids. They're cosmic siblings, inseparable. Yet here was 3I, ATLAS, bleeding nickel into space with iron nowhere to be found. Some scientists tried to explain it through exotic minerals, rare separation processes, or bizarre heating effects. But the truth was, no known natural mechanism could create nickel without iron. It was like finding a beach of gold. Dust with no trace of sand. For a moment, the whispers grew louder. What if this isn't natural at all? As researchers traced the object's trajectory backward through the galaxy, the timeline became even more astonishing. Simulations suggested 3I Atlas had been traveling for 7 to 14 billion years. To put that in perspective, our solar system is only 4.6 billion years old. This object was already ancient when Earth was still dust swirling round a newborn sun. Its likely birthplace, the galactic thick disk, one of the Milky Way's oldest and most violent neighborhoods. Stars there are relics from the galaxy's youth, formed when collisions, mergers, and explosions were tearing the cosmos apart at rates far greater than today. Chemical analysis of 3I Atlas supported this. Its isotopic ratios matched environments that existed when the universe was still young, chaotic, and far more hostile. What that means is chilling. 3I ETLAS is not just a comet, it's a fossil from an era long before Earth. Locked inside, it's frozen. Core of the conditions of a galaxy we'll never see again. Its chemistry is like a message in a bottle, drifting across time, preserved by its enormous size and its billion-year exile in the cold of interstellar space. It survived cosmic rays that would pulverize smaller bodies. It endured gravitational slingshots. Past stars, violent encounters that could have shattered it. Yet somehow, against all odds, it arrived here, still intact. To study it is to look into the primordial past of the galaxy, to touch a piece of history older than our sun, our Earth, and possibly even our galaxy's modern shape. Perhaps the strangest part of this story is that humanity almost missed it completely. Without artificial intelligence, 3I Atlas would have slipped past us, invisible in the night sky. The Atlas network in Hawaii, South Africa, and Chile scans the heavens tirelessly, capturing terabytes of data every night. But no human could process the millions of stars and faint dots those telescopes record instead. It's left to machine learning systems, trained to distinguish false signals from genuine cosmic intruders every night. The algorithms fight through thousands of distractions. Cosmic rays hitting sensors, satellites streaking across images, even birds flying past telescope lenses. Among all that noise, 3I ETLAS appeared as nothing more than a faint, moving dot. But the AI noticed something different. Its movement was too consistent. Its trajectory too strange, to be dismissed. And here's the most staggering detail: 3I Atlas was only detectable for a handful of days. Its speed was so great that had we missed that narrow window, it would have slipped through our solar system undetected, carrying its impossible chemistry back into the darkness, leaving us none the wiser. The discovery was pure luck, and also pure inevitability. Luck, because the skies happened to be clear. Inevitability, because artificial intelligence was finally good enough to catch the signal. Humanity didn't discover 3I ETLAS alone. It was a partnership with our machines, a collaboration between human curiosity and machine precision. That's fitting. Because 3I Atlas doesn't just challenge what we know about comets. It challenges what we know about probability, physics, and even existence itself. The moment the discovery hit international networks, astronomy went into overdrive. Telescopes from Hawaii to Chile pivoted toward the intruder. The Minor Planet Center in Cambridge pushed out emergency alerts. Coordinating observatories across continents, NASA, the European Space Agency, and even smaller institutions scrambled to get a piece of the action. Within hours, the James Webb Space Telescope was pointed at the object. Its massive gold mirror collected light that had traveled across billions of kilometers of space, splitting it into spectra so fine it could detect the faintest chemical fingerprints. Webb wasn't. Alone Hubble's ultraviolet instruments joined in, along with radio observatories like OLMA and the Very Large Ray. Even Mars orbiters received special instructions to prepare for October, when 3I ATLAS would pass close to the red planet. It wasn't just astronomers. The SETI Institute turned its antennas toward the visitor, scanning across frequencies for any hint of artificial signals. After all, if anything had ever fit the profile of a probe, this was it, a massive, anomalous object driving on an impossible trajectory. The result? Nothing. Just silence. Broken only by natural thermal emissions, but silence didn't erase the unease for weeks. The internet buzzed with theories. Some claimed it was a derelict spacecraft. Others swore it was proof of alien mining operations. Harvard physicist Avi Loeb, famous for stirring controversy with his speculation about Oumuamua, published an analysis giving 3I Atlas a 4 out of 10 inches probability of artificial origin. NASA pushed back hard, issuing careful statements that the anomalies could all be explained by natural, if rare, processes. Still, the debate had already escaped into the public, and the object had become more than science. It had become myth. The numbers surrounding 3I Atlas weren't just strange, they were absurd. According to every population model, interstellar objects should follow predictable distributions. Small ones should vastly outnumber large ones, following a power law. That's why Oumuamua made sense. A thin, dark shard only a few hundred meters long. Even 2I Borisov, at about 1 kilometer, was within reason. But 3I ATLAS, at 7 miles across, its mass is more than 10 million times greater than Oumuamua. Statistically, astronomers should have discovered millions of smaller interstellar visitors first before ever glimpsing something this colossal. Yet it appeared as our third known interstellar guest. Then there was the orbital alignment. Random visitors should arrive from any direction, spread evenly across the imaginary sphere around our solar system. But 3I ATLAS approached at just 5 degrees off the ecliptic plane, the same plane where Earth, Mars, Jupiter, and Saturn orbit. The chance of this happening by random alignment, less than 0.2%. Combine that with the retrograde motion moving against the flow of planets and the odds drop even lower. Finally, there was the timing. 3I Atlas just happened to pass at a distance, and brightness perfect for detailed observation during a window when Webb, Hubble, and Mars orbiters were all active. If it had arrived a decade earlier, or a decade later, humanity would have missed it completely. The combined probability of its size, trajectory, and timing left professional statisticians shaking their heads. By some calculations, it should have been less likely than winning the lottery thousands of times in a row. And yet, there it was, bright, massive, undeniable, a visitor that shouldn't exist. But Dow's astronomers had one date circled in red, October 30th, 2025. That was when 3I Atlas would reach Perihelion, its closest approach to the Sun. For comets, Perihelion is the moment of truth, the time when sunlight sears through surface layers, triggering spectacular outbursts of gas and dust. It's when comets grow tails millions of kilometers long, visible across the sky. For 3I Atlas, models predicted something unprecedented, a tail stretching over 100 million kilometers, nearly rivaling the distance from Earth to the Sun. It could have been the most spectacular comet display in human history. But nature played a cruel trick. During its closest approach, 3I Atlas would be in solar conjunction, hidden directly behind the blinding disk of the Sun from Earth's perspective. No ground-based telescope would see it. Even Hubble and Webb were forbidden to point that close to the Sun for fear of damaging their instruments. For Earth, the grand finale would be invisible. Astronomers called it a tragedy of timing, a once-in-history event unfolding in total secrecy, cloaked by the sun's glare. But all was not lost. Mars, positioned on the opposite side of the solar system, would have a perfect view, the Mars Reconnaissance Orbiter prepared to train its ultra-sharp cameras on the object. The ExoMars Trace Gas Orbiter would sniff its emissions, and Europe's Mars Express would map its composition in infrared. For the first time, interplanetary spacecraft would become our eyes, relaying the cosmic show back to Earth with breathtaking clarity. Still, there was something deeply symbolic about it. At the moment of its greatest display, this ancient wanderer would remain hidden from humanity. We would catch only the beginning and the aftermath, missing the moment when its billion-year secrets burst into sunlight. The more scientists studied 3I, ETLAS, the more it became clear. This wasn't just another comet. It was a messenger from cosmic noon, the period 2 to 3 billion years after the Big Bang, when galaxies were forming stars at 10 times today's rate. The isotopes inside 3I Atlas carried fingerprints of stars long extinct. Its chemical balance reflected conditions when the Milky Way was still young, chaotic, and violent. Back then, supernovae exploded constantly, flooding space with heavy elements. Planetary systems formed in chemical environments completely alientos. Most of those materials are gone now, recycled into new stars, new planets, and new dust. But 3I Atlas preserved them, locked in ice, and touched for billions of years. To study it is to touch an era when the galaxy itself was still learning how to build planets. It's not just a comet, it's a time capsule older than Earth itself, carrying memories of how the universe grew up. Some scientists went further. They proposed that objects like 3ETLAS aren't just relics, they're couriers. Theories of panspermia suggest that life, or at least the raw ingredients of life, may travel the galaxy aboard comets, asteroids, and interstellar visitors. 3.1 ETLAS certainly fits the bill. It carries carbon chains, cyanide compounds, and organics that could act as building blocks for biology, and with its immense size, it could survive billion-year journeys intact, delivering those ingredients to newborn planetary systems. Imagine a young star forming a new solar system. Its protoplanetary disk is swirling with dust and gas, but it struggles to form large bodies. Then an object like 3I ETLAS drifts in, already massive, already loaded with volatile materials, captured by gravity. It becomes a ready-made seed. Round it, gas and dust collect, accelerating the birth of planets. In that sense, 3I Atlas might not just be a fossil. It might be a gardener of the galaxy, scattering seeds wherever it goes, shaping worlds and perhaps even sowing the conditions for life. By December 2025, as 3I ETLAS emerged from solar conjunction, Earth-based telescopes would finally see it again. What they found would be either triumph or tragedy. Some models predicted it would fragment under the sun's intense heating, breaking into smaller pieces. Others suggested it would survive intact, trailing a tail longer than any in recorded history. Either way, astronomers knew one thing: this was humanity's only chance, once it swung past the sun. 3.1 Atlas would never return. Its hyperbolic path guaranteed it would disappear into the black, carrying its secrets beyond the reach of human science forever. What does 3I Atlas mean for us? On one level, it's a scientific puzzle, an object that defies our models, forces us to rethink planetary formation, and proves that the galaxy is stranger than we imagined. On another level, it's something deeper. It's a reminder that our solar system is not typical. that our assumptions about water-rich comets and Earth-like worlds may be rare exceptions, not universal rules. That carbon dioxide-dominated environments may be the true norm of the galaxy, and maybe, just maybe, it is a reminder that we are not alone in the cosmos, not because 3i, Atlas, is a probe or a spacecraft, but because it shows us how connected the galaxy really is. Material is exchanged, objects are flung, seeds are scattered. Our Earth may not be isolated at all, but part of a vast network of cosmic exchange stretching across billions of years. 3.1 ETLAS is more than a comet. It is a messenger, a scarred refugee from another star, a gardener of worlds, a time capsule older than our planet. And as it continues its eternal journey into the dark, it leaves us with one haunting truth: the universe is stranger, older, and more improbable than we can ever imagine. If you found yourself captivated by the mysteries of 3i, Atlas, if you felt the same, or scientists did when they first realized what we had discovered, then stick with us, because this is only the beginning. The galaxy is full of wonders, and every one of them carries secrets that could rewrite the story of life, planets, and the universe itself. So the question is not whether we'll see another. The question is, what impossible thing will we discover next?